All right. So, questions from homeworks or just questions in general. We can kind of do either right now. So you guys had been working on that, that worksheet number 7 that I gave you guys in class last week, and you had homework 6 that would have been checked on Sunday. Kalila? Yeah. Sure, no problem. So synthetic division is just a shortcut that we can use. So let's say we have the polynomial here, and we want to divide this polynomial by, say, x plus 2. Okay with that? So first thing, to do synthetic division, the divisor has to have degree 1 and the leading coefficient of 1. That means it has to have just like x to the first and then a constant, which is what we have here, right? Is that okay? Okay. So the way we set up our synthetic division is we draw like our synthetic division bar, and then we take whatever our divisor is, set it equal to 0 and solve. And that's the number that's going to go on the outside of our synthetic division setup. And then the coefficients from our dividend are going to be the numbers inside of our synthetic division setup. The one thing we have to be very careful about there is that we can't have any skipped terms. So notice in our polynomial we have to the x to the 5th, 4th, 3rd, 2nd, 1st, and then constant. So we didn't skip any terms. If we skipped a term, though, we have to put a 0 in place for the one that gets skipped. So if this thing was like missing x to the 3rds, we put a 0 where the x to the 3rds would have gone. Is that okay? We didn't have to do that in this case, but that's something we have to be careful about. Okay, so that's what the starting point looks like. So the first step is just to take the first number and put it underneath. And then what we'll do is we take the number on the outside, multiply it to the number underneath, and write it in the next open place, and then add down. So I did -2 times 1. I wrote that -2 here, and then added down to get 0. And that's the step. I'm just going to keep repeating that until I'm at the finish. So now I'm going to do -2 times 0. That's 0. Put that in the next spot, and then add down. Gives me -2. Then I do -2 times -2. That's 4. I add down. That's 0. And then -2 times 0 is 0. Put that in the next spot, and I add down. That's -3. -2 times -3 is +6. Put that in the next spot, add down, and that's 0. So the division now is complete. We just have to remember how to read our answer. So we always start at the number on the far right. That number is the remainder. And the next number is the constant term, the x coefficient, the x squared coefficient, x to the 3rd coefficient, and x to the 4th coefficient. So what we can say then is x to the fifth plus 2x to the fourth minus 2x to the third minus 4x squared minus 3x minus 6 divided by x plus 2 is equal to 1x to the fourth. I'm not going to bother to write the 1. 0x cubed, I'm not going to write that at all because it's a 0 coefficient. Minus x squared plus 0, or minus 2x squared, excuse me. 0 x's, I'm not going to write those, and minus 3. And then because it's remainder 0, there's nothing else at the end. The other way I can think about this, though, is I can use the synthetic division to do factoring. So the other way I can think about it is that this polynomial x to the fifth plus 2x to the fourth minus 2x to the third minus 4x squared minus 3x minus 6 is equal to x to the fourth minus 2x squared minus 3 times that divisor x plus 2. So that's how we kind of do the synthetic division, and that's how we kind of interpret our answer, depending on what we're trying to do the synthetic, or what we're using the synthetic division to do, whether factoring or just dividing, might change the way we write our answer afterwards. Stefan.
Could you walk through what you just said, everything from the last number you wrote in? When you finished the synthetic division chart,
Okay.
what you did.
Okay. So what we then need to do, after we finish our synthetic division, we need to interpret what our answer means. So we always start at the far right. The first number on the right is the remainder, and then our constant term, and then our coefficient for the x's, coefficient for x squared, coefficient for x cubed, and coefficient for x to the fourth. And we just kind of keep going up 1 degree as we move from right to left. So what we can say then is that our original problem, x to the fifth plus 2x to the fourth minus 2x cubed minus 4x squared minus 3x minus 6 divided by x plus 2 is equal to 1x to the fourth, 0x cubed, I didn't bother to write that, minus 2x squared, 0x, not going to write that, then minus 3, and because the remainder is 0, there's nothing else to write there. So the other way to think about this is I can think about the synthetic division as a method for factoring. Since the remainder was 0, I can also say that my original polynomial is equal to the quotient times the divisor. So just a different way of writing that answer depending on whether we're using the synthetic division to do division or if we're using it to do factoring. So just kind of depends there. Does that feel okay?
Yeah.
Okay. Kalila, were you happy with what I did there? Okay. Did that help? Okay. Good. Good. And again, like to do the factoring we've been doing here, you got to be good at being able to do synthetic division, and you have to be good at interpreting kind of what the synthetic division is telling us, right? Those are all really important skills to have. What else do you guys want to talk about? I'm happy to do more, and they could be specific homework questions, or they could be broad things like, hey, can we do another, go through the details on how to do this thing or that thing? That's all really important. Ben?
Can you do number 3 on homework 6?
Sure. Let's grab homework 6. Okay. So here we're asked to factor this completely. So we have a bit of work to do, observing with the fundamental theorem of algebra that because this is a degree 8 polynomial, it should have 8 solutions, or at most 8 factors. And then I can determine the possible rational factors for this are going to be the factors of the constant term, 16, divided by the factors of the leading coefficient, 1. Since we're dividing by 1, that doesn't really do anything. So I just need the factors of 16. And then I'm going to go to my calculator and type this polynomial in and look at the graph to try to see which one of those rational roots seem like good candidates to do the synthetic division with, and how many times I might be able to use the synthetic division on each one of those roots. So I'm just kind of stalling here while my computer opens up my calculator function, because it's going like I have too much stuff running, I think. So I have x to the 8th minus 10x to the 6th plus 33x to the 4th, 33x to the 4th minus 40x squared plus 16. Okay. Now, the way I like to look at my graph here is I like to set my window personally. So I use my x min, the smallest number for my RRT list, so that would be negative 16. And my x max to be the biggest number for my RRT list, that would be positive 16. And then typically I just use negative 3 and positive 3 for my y mins and y maxes. Now, I may end up having to change all of those things depending on what my picture looks like to really get a good idea of what's going on. But that's my initial spot. If you guys can't see anything, please stand up and turn off the light. I think that's what Stefan's going to do right now. Thanks, my dude. So I'm going to go ahead and hit graph and take a look at what this looks like now. Again, I may end up needing to zoom in some more, readjust my window, but I usually pick a bigger window than I need just to make sure I don't miss anything, because I'm not totally sure what I should be looking for. And it is doing stuff. You see at the side there, it's that bar moving is telling you the calculator's thinking. Okay. So some stuff happened here. It looked like most of it happened between like -2 and +2. So I'm going to readjust my window, and I'm going to go from like -3 to +3, just in case there's like looked like there's some possible bounces going on there, and I just want to make sure that I can see the bounce going on if there's one happening at -2 or +2. So that looks like a bounce at -2, a bounce at -1, a bounce at +1, and a bounce at +2. Do you guys agree with that when I'm looking at how I interpreted that? Okay. The total has to be 8 because there are 8 solutions. And since each one of these guys were bounces, I know the minimum number of times that a bounce can occur is 2. I noticed that all of the x-intercepts I saw were rational, so I have no irrational things. And if I add up what I have there in the table, 2 plus 2 plus 2 plus 2 is 8, leaving me no room for imaginaries, or really no room for something else to happen. So I know that this is how it's going to factor. I just have to confirm that now using my synthetic division. So let's just start maybe with the -2. It doesn't do -1, +1, or +2. It doesn't really matter. And then I'm going to start my synthetic division. Now be careful here because we have lots of skipped terms. We have no x to the 7ths, x to the 5ths. We have no x to the 3rds. We have no x's. I set up initially. So bring the first one down, and then we just kind of rock and roll through this. So that worked. Go ahead and use it a second time right away. because I know I knew I could use it twice because it was a bounce. So bounces occur in even though I use something twice. Sometimes they can only be used once. Sometimes they could be used twice, sometimes 3 times, sometimes more than that. You're getting on your calculator. Absolutely. In this process, where you really need to spend good time is when you're, because you can really tell a lot of information. Yes, of course. So I've done my -1 and do this twice because everything I saw was a bounce. So but I like where I'm going here because each time I do one of these synthetic divisions, you'll notice that. So what I'll do here is I'm just going to write down what I've got so far. I'll show you in just a second. Keep going. It's not wrong to do that. I just think it's going to be a little bit quicker to not. -2, that gave me a 0 remainder, right? So that gives me a second x plus 2. I have -1 that gives me a 0 remainder. That gives me a factor of x plus. And so on and so forth, right? Is everybody okay with how I've gotten those guys down there? Now the last piece that I have is that part right there. Since this has only 3 terms, my factor, and in fact, I don't even really need my factoring tree because this is a chapter factoring problem. So the 2 numbers that multiply to give me +4 and add to give me -4 are -2 and -2. Are you happy with what happened there?
Yeah.
Did you forget the zeros in the synthetic division?
No, I just did it wrong. I did like one of each, like the -2 and then the -1. I like do it twice.
Yep, and again, you could do those each one back and do them. You would have needed to do there was catching that those were bounces was, very important. Leo.
Now can you make it equal to 0?
Yeah. So for part 6 then, or for number 6, thing equal to 0. And solve, and I'd like you to write them out with the number of times they're used so that the number of solutions matches the 8 predicted solutions. Stefan.
Could we do a quick recap of your calculator work? Like after you get it
For this problem?
Yeah.
Sure.
After you write out y equals, and I think it's the zoom window.
So I usually go and custom choose my window. So I usually pick, I usually press the window right next to it. Now, this was not the first shot that I took at the window though, Stefan. So the first window I used was from -16 to +16. What I used to pick those y positive and -16 is because those were the biggest and smallest values from this RRT list.
Okay, so you write that in x minimum and x max?
Right,
Okay.
and the -1 has to go in the minimum and the positive. Now, when I looked at that graph, I could see that most of the stuff I cared about happening much closer to 0 than that, so that's why I chopped down to -3 and +3. Does that make sense?
Smaller number off of that.
you shouldn't, because it's very possible you have something.
Okay.
Like, those are your possible things that you can use to do the synthetic division, go from negative 16 to positive 16. If you started at the beginning, it's possible you missed something important. So you always want to start with that bigger range down, then you can narrow down to get a better picture. But you don't want to like start too narrow and end up missing stuff away. Does that make sense?
Yeah.
So if I had started at like -3, but like maybe -8 was one of the x-intercepts I was going to have, because it was certainly on that RRT list, I would have missed that. And then it would have made the problem a lot harder to end up at the right answer, because I would have been like, what is missing? Like, what's going on? You know what I mean? So that's why I always start with the widest possible view, and then I can zoom in and get smaller. Did that
Yeah.
feel okay? Okay. So when I look at the picture, the zoomed in picture, I'm looking at the x-intercept, so the place the graph is touching the x-axis. So there's 4 of those. I could tell before this stuff graphed in that this was at -2 because there's a tick mark there. That was at -1 because there's a tick mark, +1 and +2. And then because the graph is going and touching the x-axis and then going back the same direction it came, that those are bounces. The other options are straights, where it just passes straight through. Straights are used only one x-axis and then curves the other way. Those are used an odd number of times, so like 3, 5, 7. Bounces are even, 2, 4, 6. Straights are once, only once. Does that feel okay? Okay. Lovely. All right, here, folks. How are you guys feeling? Meh. All right. So let me put in the homework quiz, and we'll start that. Okay. I'm going to put that homework quiz in the content library. Once you finish with the homework quiz, you'll want to publish that as a PDF and upload it to the Dropbox on PowerSchool. I'm going to make that Dropbox in just a second. When you've finished doing that, the Chapter 5 review is in the content library also. You can start on that if you're ready to do that. And once everybody's turned in their homework quiz, we'll talk about the test format and that kind of thing, okay? All right.